just going to introduce the class examples so that tomorrow we do the class exercises. It's easier like that, and I'm able to manage my time much more better. So, but I might ask us to do one uh, class example so that we skip it tomorrow. So, and maybe introduce the software so that we do not find ourselves needing to repeat the software tomorrow, because tomorrow, sure, we have to finish, you understand? So, and yeah, guys, I was attending graduations today, so I couldn't, there was no way I could have started at that time, which was 12 o'clock. And even now, I was delayed because of I needed to still revise. Uh, so I do not like uh, reading in front of you guys and getting confused and stuff like that and not know what to do and have to refer every time. It's not nice. So yeah, I'm gonna keep the class short. As you see, we started very late, so there's not too much to do, but it's very critical. It will assist me to have a second question. So one of the questions will come here, one from MRP. Yeah, so Branson Machining Incorporate manufactures driveway security fences and gates. It wants to develop an input-output report for its welding center for 5 weeks. Okay, for 5 weeks. Then the planned input is 280 started hours per week, standard hours per week. So it seems like the planned input is the same. You see the planned input it remain constant. That's what they've planned to do. And uh, this could be because they want to satisfy a demand that comes from your MRP. You see at the end of the you have planned order release, and then we have order release. So this is what they receive, and they need to uh, produce based on the demand so that they can be able to meet the demand. So the actual input close to this figure vary. The actual input is close to this figure. However, it varies. So now, reality is when you plan and your actual, obviously, we plan, all of us. I'm gonna wake up at 8 and bath and go to campus and study for 2 hours. Tomorrow you wake up at 9, you watch a movie, and then you bath at 10, and at 12 you go to campus, at 3 you go to class. You see now your plan is, yeah. So things don't go according to plan. That's reality. And then so it varies between 250 and 280, which is around about here, right? Then output is scheduled at 320 standard hours. Output is here, output, planned output. So um, so this is in time, standard time. So planned, their planned output is 320 hours. So which is assumed capacity. This is their assumed capacity. This is how much they can produce. Okay. Then a backlog exists in the work center, right? So now for this exercise, we're going to do what is called cumulative deviation. Cumulative deviation, we want to calculate between the planned input versus your planned output, right? So now remember this, the input could easily be the planned input could easily be the demand from your from the customers, né? So you need to always meet that by your actual input. Otherwise, you might not be able to satisfy the actual demand, right? So the formula to take on the difference is, you say actual input minus planned input. So this, when you are having a good production, you need to have it as either a zero or a positive figure. Then in this case, we have you planned more, but you utilize less. So that is a negative 10. You plan more, you utilize less. What you desire and what you do. So they you subtract from what you are able to do, and the remainder is a deficit. Then we have now 250 minus 280. We have a 30 there. As you can see, 250 minus 280. We have a 30, which is a negative, and we add the negative 10. That makes it a negative 40. So we'll start with maybe 6 over 6, which is 270 minus 280, which is equals to 10, and then 6 over 3, which is 250 minus 280, which is equals to negative 30 minus 10. So we're adding the 10, then it makes it a negative 40. In case people are wondering how did we get that, that's how we do it. Okay, then now we have a 40 on hand. Do you see here? Do you see here that we are now having what? This one here. This one, it's a 0. 280 is a 0. However, we still have a deficit of, because we're doing cumulative, of negative 40. Then now things are starting to change. 85 minus 80 is a positive 5. Then it reduces this one to become a negative 35. And then this one becomes a 0. Actual input needs to always be balanced.
Can you please repeat there for negative 35? Can you please repeat?
Okay, let's actually do it. So now remember that our formula is this thing likes drawing. It's 285 minus 280, which is equals to 5, right? Then the 5, we have a 40 there. This is now minus 40, which is going to become negative 35. And in principle, we're supposed to do this one, but we didn't do it. They didn't do this part. Maybe because of it doesn't correspond with what with our outputs here. So maybe that's why. Then now this side we have what is it? The actual output and the planned output. Your actual, it's what you are really giving, 270, and you've planned 270 and you've planned 320. This is what you desired, and you are ultimately not getting it. So what's your difference there? 270 minus 320, which is negative 50 now. So you're not getting what you're looking for, and you're setting at negative 50. That's your negative 50 there. Then we have now, this is the same thing, 220, that it's another negative 50. So minus negative 50 is equals to negative 100. Negative 100. Then we have 320 and 270. It's the same thing, as you can see, negative 150, negative 200. So we are not able to meet our production by negative 200 here, and by negative 35 there. Okay, then we have what is called a cumulative change. Then this one is between your actual input and actual output. So this is how it's going to be like. So I'm going to do this straight line. Okay, and then go down. Doesn't want to listen. Okay, that's fine. Whew. This digital pen, sometimes it's acting up, but it's fine. Right, and then let's go down. Okay, that's fine. We then draw it this way. Yeah. So this two, okay. Then so 270 and 270, actual input now, what you are putting in, your actual input and your actual output. You are getting a 0 on this one. Your actual input and your actual output, 70, it needs to be a positive. Then now, on the side of your, and then here I believe it's supposed to be 250 minus 270, and we're getting a negative of 20. So actual input, as you can see, actual inputs minus sum of actual outputs. So now actual inputs is actual A in, it's what we are desiring, minus actual output is what we are able to put in. So now we want 250 minus 320. Although we produced more here, in this case we produced more by negative 20. This one is actually, it's supposed to be more, because remember, whatever you put in, if it's less and you get more, eventually that's not supposed to be. I'm looking at the wrong things, guys. This is okay here and there. Yeah, so we are okay. This is their formula, ne? It's not my formula. Sum of actual inputs minus actual outputs. Okay, so inputs, which is in 250 minus 270, so that is negative 20. So here we have a negative 20. Then we continue. We have 280 minus 270. But because of 280 minus 270, we have it as a 10, but we have a negative 20, so it becomes minus 20, then becomes a negative 10. This one becomes a negative 10, right? Then it's going to say 285 minus 270. We have it as a positive 15. Positive 15 minus 10, we have it as a positive 5. Okay, so you are loading here small and you're finding big. Yeah? So the positive, the negative here, it's not supposed to be a bad thing. This is like your production date is 6 and your due date is it's 8. So you have a difference of 2 days there. When the value is negative, it means that you do not have any, you are not late. But when your value is positive, that's when you are late. There's that concept that you will see when we're doing when we are doing other analysis. So let's read on the insights what they are saying, because at least they have written something. Okay, so according to what they've said here, so then input and output it's 270, which implies that there's zero change. All right, move right along. And then which is here now, this one. So we have it as 250 and 270. Then based on the formula implies that 20 negativity change. Yeah? So this is 20 standard hours less work in the work center. So that is less work, not more work, less work. You see that this is what it means. That's why it's a negative. That's why I said sometimes getting a negative is not a bad thing. As compared to your actual, your planned and your actual, they are catastrophic. These are what you are short, you are unable to deliver because you are planning this. This could be coming directly from MRP as order release, so they are placing an order to you and you are unable to actually meet its demand when it's like that. Although the book, unfortunately, I think it didn't explain much on it. If otherwise, please refer to the book and check what is really happening. And then, so now they also continue to say the deviation between scheduled input and actual output are shown in figure 15.2. Actual output 270 is substantially less than planned. 270 is actually less than what is planned. There, it's actually less than what is planned by 20. They've planned 20, they're getting more. So that's actually less than what is planned. Okay, then therefore neither the input plan nor the output plan is being achieved. Okay, because you need to get a zero. A zero is when you are meeting your target. Then they say the backlog in this work center has actually increased by 5 hours. You see now, by 5 hours. This 5, the positive 5, is the one that is actually a problem in this case. Those other ones are deficits. These other ones are deficits, yet they're not a problem. They just, you have under it's more like under planning. Yeah, and it's under planning, and you need to be able to meet the target when you're getting 0-0. However, this positive, it's not a good sign. It's actually your workload going up. Okay, so this example ends here. When we do it in class as a book on the book exercise, it will definitely change slightly. Ne? But I'll try to make it a point that whenever I ask in the Conjure, I've released I've given away the exam. I must just check what type, because I said it does change slightly. I need to understand which type did I use in the exam, so that at least I always test you in what is gonna come. This section here. Now this section is not even in a test, guys. So you mark it out, prepare it for exam. Ne? Mark it out. So you send on record. Remember, we are the ones who are setting the test and the exam. And you guys, if you fail to listen to the very same people who are doing these things, it becomes a problem. It doesn't serve me right to take you off track, to lie to you. It doesn't serve me by anything, basically. You need to understand that fact. It doesn't serve me by anything. Your failure, it's not another 2 rand on my pay sheet. It doesn't mean that. So I achieve nothing. In fact, I achieve a lot of stress. So for this one now, this is for I don't know why they wrote. We were supposed to be reading this, not that. I don't know why did I put this there, but I understand I was still fairly new. So, but this is what we are trying to do here on this example. So, what is it required? A first printing wants to find a minimum total cost, the least cost of 3 jobs and 3 typesetters. Ne? So we are doing assignment. Ne? So this is actually not necessarily job sequencing. It's now we start with assigning. It looks like transportation. We have, I think we have done transportation, a method. So it's something similar to it. But now we are assigning. Ne? We are assigning on this exercise. So first thing first, when we are having this as a, I just want to fill up this information here. R34 S66 then T50. Okay. When you are having this, you start immediately here. You don't rewrite them here. You start by calculating. So there's a rule that they use when they're assigning it for minimize. Then for maximize, it will work differently. Keep that in mind, ladies and gentlemen. It will work differently. So for minimize, we start by horizontal, like this. You look for values that are small horizontally. So in this case, which one is small horizontally is 6. What do we do with the 6? We minus with the 6. 6 minus 6, then 14 minus 6 is 12. And 11 minus 6 is 5. Okay, that is a 5. We move right along. Which one is the least again? It's 8 on this row. So 8 minus 8 is a 0. 10 minus
That 14 minus 6, isn't it supposed to be 8?
Thank you so much. Didn't I say 8, but I wrote the opposite?
Oh, you said 12.
I said 12. Wow. Thank you, man. So here it's 2, as you can see, 8 minus 2, and then 3 at the 11 minus 8. Okay, then we're carrying on here. It's a 0 at 7. 7 minus 7 is 0. 12 minus 7 is 5. And 9 minus 7 is 2. Okay, and then we need to do this. We repeat again, but we are doing it vertically now. So we are going to only target sections that do not have numbers. here we do have zeros. The sections that do not have zeros, here we do have zeros here, and also this line we do have zeros. Therefore, we don't touch it. With that, do physical vertical of this one. So everything else remain the same. 0, 3, 0. Here we do it with 2. This one goes down 3. Here becomes a 6. Then 5, 2, 0. They remain. Then we need to do what? To put the lines. Now our lines goes like, we need to change the color. Our lines goes like this. And like that. Okay, so this it's not yebo boo. You can talk.
Where is the 6, 0, and 3 on B coming from?
Okay, so remember I said we are going to only substitute the list here when we are looking at vertical. Now we are doing vertical. Here it's actually vertical subtraction. Vertical subtraction. Here is horizontal subtraction. Ne? So now doing it vertically, this is the only section that didn't have a 0. So now 2 minus 2 is 0. 8 minus 2 is 6. 5 minus 2 is 3. Then everything else remains. I hope it's understood. Then we carry on. The solution is not reached in this manner. The solution is not reached because we want to cover everything. Once you have the solution, it's when you cover everything. When you cover everything. Okay, so now we are going to say this. We haven't yet reached our solution. So the method we're going to do, we're going to take these two, utilize it to substitute everywhere on the stuff that are not covered, but we add it on the section whereby it is intersecting. So what does that mean? We're going to say 5 minus 3, 5 minus 2. 5 minus 2, actually, we start with the 2. 2 minus 2 is a 0. This one is a 0, 0. And then we're saying 3 minus 3 plus 2, this one becomes a 5. 0, 0. 6 of 2 minus 5 is a 3. 2 minus 6, it's a 4. Then we have 3 minus 2, it's a 1. Now we are able to find a solution here. There's a 0 here and there's a 0 here. We are able to highlight all of them. Okay, then after we need to find the solution that gives us the least cost. So we need to be able to assign. So now when we assign, the solution found, it was found. I still don't have a real proper explanation. Maybe it's because I took a little time to prepare the way I wanted. I didn't have enough time because I didn't get to understand this topic last semester. But it's a very interesting topic. And this is how they find their optimum solution. So the optimum solution, you go back to your first table. Né? You mustn't forget that. You go back to your first table, then you do this. You highlight this, you highlight that, and you highlight this. So this is where you're gonna find the least cost. This is where you're gonna find the least cost, and when you add them together, they become let's say, actually usually what they how they write it, they would say your solution is found at 334C and S66B, then T50, which is A, then it becomes your 6, 10, and 9. Your answer now becomes what? 6, which is 16 there. 16 plus 9, which is 25. Okay, then we can still go to the explanations and see what they have done, because I'm also interested. I still need to revisit this chapter to understand a few things, because my solution slightly differed, just slightly, but I have to always follow the book and read what, and I will definitely understand what is happening. So remember when we added the 2, so this is the 2 that we had here, so we needed to add it here. So that's why here they have a 5, because we were adding the 2 there. However, we were minusing it in all the other sections that are there. Then cover the zeros with a straight line. So all sections that have a zeros, we cover them with this. Okay. Then now, because 3 lines are necessary, an optimal assignment can be made. See step 4. Where's step 4? Okay, I do not have step 4. Maybe I need to check step 4. How did they explain the process of finding this? So S66, we could not assign T50 to a 0 location. To a 0 location. What do you mean? Because I thought that it was one of the. So they say if we had assigned. So my solution basically, I2 was coming here, there, and there, but they're saying that they couldn't. If we would have assigned S66 type sector A, we could not assign T50 to a 0. We could not assign T50 to a 0 location. It needs to be analyzed why it says 0 location. Because we started with a 6. 6 gave us a 0. Who else gave us a 0? Was an 8. And followed by this one. Okay. And lastly, this one. But the explanation there is still ambiguous. Maybe something that a person needs to explore through AI and get the proper explanation there. Yeah, because we definitely need to know what is it that we are trying to do. So I'll do that investigation, and I'm also giving you the powers to do the investigation by yourselves also. So, ladies and gentlemen, let's move. Let's move to the section here. So here, what we have your sequencing, job sequencing. So this, when we are doing LIFO, and LIFO, I know it as LIFO. First in, first out, ne? So that is, oh, FIFO, first come, first serve. That's the terms that they use in the book, right? And then we have another one, which is LIFO. LL, last come, last served. You see these ones, the sequence they use, it's here. You arrange based on this. Ne? You arrange based on this. Whenever you are, yeah, it's fine like this. Whenever you're dealing with this, you assign according to that. But the moment you are saying that you have your short processing time, long processing time, wait, there were terms here. Okay, long processing time, short processing time. We are doing that, right? Then, whenever you have earliest due date. Okay, I didn't make this one is that. So whenever you have earliest due date, EDD, earliest due date, you solve. You sort these. You sort according to that. You see now, you sort according to that. So once you understand this section, you will definitely pass this. Then there's another one that uses some weights. Yeah? They are called critical ratios. So I think you find some numbers here, you multiply with a certain number and you sort according to whatever that number you are getting. Ne? So that one we will see as we get into the book exercises tomorrow. Okay, but there's something I wanted to cover here. Can I go back? I hope this is clear, but I want to go back here. I want to attempt to do this for maximum. So this is for minimize. I want to attempt to do for maximum. You see this one? They are minimizing, okay? Then this one, determine the assignment jobs to match that will maximize total production. So that is maximize, A, maximize. For which, or for both of them, for the, I don't understand here. Here you try to minimize driving distance to customers, yet here you are trying to maximize the total production. Oh, but okay, obviously, or maybe these are two different things, because when this is here you have to minimize. Okay, so this is you minimize the distance here to the what? To the customers. You see, taxes to customers, so as to minimize the total distance to the customers. So, but here, these are the machine. This is for the production. Therefore, this one becomes maximize. You want to maximize the production. So when you are doing this, we are doing the maximizing of the production. So where can I start? I'll start here. So So the rules have changed slightly. It is now stated that Okay. I need to erase, obviously, guys. This was last used last semester, and I didn't have enough time to prep myself for it. Okay, then usually it ends on the second. For some weird reasons, it ends here. Okay, and we're going to introduce the software. On the software, we'll cover the book example, and we find the solution that they found with the software, right? So now, I said to you, the best way is you do not rewrite the first section. You rather super thirsty. I need to get myself water. Give me 2 seconds. My water, my throat is complaining. Yes.
Everything is to I don't qualify who professor. How does you? There's in Jakarta suit. Already one bonds have now. Eh? You can't give a full life. Yeah, come and consult Professor Wayne. Sikautia lile alipandula yeye. Yes.
I will bounce gas. Okay, so now I see an important note here that I need to cover. It says some assignment problems entail maximum profit, effectiveness, or payroll of assignment of people to tasks or jobs to machines. Okay, an equivalent minimization problem can be obtained by converting every number in the table to an opportunity loss. To convert a maximizing problem to an equivalent minimization problem, we create a minimizing table by subtracting every number in the original payoff table from the largest single number in that table. So now, when we find this as maximizing, in order for us to be able to move it into minimization, we need to subtract what? The largest number on the table. We proceed to then we proceed to step 1 of the 4-step assignment method, minimizing the opportunity loss products the same assignment solution as the original maximization problem. Okay, so now we come here. Because of its maximization, we then look for the largest value here. Which one is it? It's 11. The largest. We substitute everything with 11. Okay? Then remember, we are dealing with absolute values here. We do not have negatives. So 11 minus, we'll start from the top there. 7 is going to be 4. Change the pen to be red. It's going to be 4. 9 minus 11, it's going to be 3. No. Let me just write. It's 2. Then with 8 is 3. 2, 3, 1. Okay. Here, 1, 2, 4 with 7. With 6 is 5. And then with 11 is 0. With 5 is 6. With 9 is 2. With 6 is 5. With 8 is 3. With 5 is 6. With 11 is 0. With 9 is 2. Okay, then now we conduct the normal, our normal vertical now. We're doing the horizontal, I mean. So we're doing the horizontal, subtract horizontally with the smallest. But we do not subtract where there are zeros. As you can see, the two lines are having zeros. Okay, so we're going to subtract it there. 1 minus 0. 1 minus 3 is 2. 1 minus 2 is 1. And then this one becomes 3. 1 minus 0, 1, 0. 1 minus 2 is 1. Then 3. Then 4. This one is a 0. So it remains, it is. This one is a 6. What is this one? Oh, remain the same. 6, 2, 5, 3, 6. Okay. 0 and 2. And then now we're going to do this vertically. We're going to do this vertically. So vertically, this remains the same. 0, 4, 5, 3. Here, which one is the smallest? Is 2. 0, 3, 2, 6. Here we do have 6, 1, 1, 6, 0. 3, 0, 0, and 2. So now the common principle here is you have found your solution because all the rows, they have at least a 0. And all the columns have at least a 0. So then the optimum solution is achieved. Okay, and then that's your optimum solution. So now the big question is, what is your solution here? And according to me, my solution is found here, and here I see a solution. And here. Okay, and here. And there. Okay. We'll do this using the software, ne? We will do this using the software. because another person can argue why you're not taking A2. So I still don't have justifications right now, but let's see what will software do. So now I'm removing this, bringing up the software, and let's see the solutions that are derived by the software, starting with the first example that they have achieved. Okay, and this problem comes again. These things they'll give you a problem. This assignment, né? The third one, assignment. So this is the one. We have number of jobs 3. Okay, and it's minimized for the first one. Okay, and then on the first, which is the book exercise, we had 11, 14, 6, 8, 10, 11, 9, 12, 7. And R34, S66, T50, and solve. Okay, and assignment list, the marginal cost, okay, doesn't really explain anything here, so but you can be able to get the solutions easy like easy. So now I'm now curious about this maximizing problem that we are doing. It has more, it has I think 4, and it's a maximize. There's 4 tables, and we have 7, 9, 8, 10, 10, 9, 7, 6, 11, 5, 9, 6, 9, 11, 5, 8. Okay. And we have our solution in this way. Okay, firstly they took there was an explanation that I found. Okay, it says when you compare here and there, taking from the 1 year 0, it come once, no? Then it appears once, meaning you cannot take the solution in the same solution in either this direction and that direction. It mustn't repeat. So now it was a 10 here, then here we're supposed to take according to what we have achieved. We had a 0 here, we're supposed to take a 0 here, but we didn't take a 0 because already it's in the same assignment as that. We needed to assign differently, so we skip it. then we go to the one here, B, then after that we go to C, then the remaining one, which is the least according to the calculations, my calculations, and we took 2, and then we had to take 2. Okay. So what does that mean? So our solution here, we already have a solution here. We've already highlighted. Our solution is this one. Starting from this, our solution is that. And when we come here, this appears to be our solution, but it's already covered. So we then look for something else. And then if we were to take the second list, then this is the second list. And then this one, the list is it's here. Then here, because of already it has been covered, then the solution gets to be moved up there. And I think if we are using the similar philosophy, if I were to go back there and analyze why they got the solution, why they got it, it will be, if you come here, what is the one that the 0 is this one. Here it's this one, but here there are 2. But remember that there's already a solution that has been discovered here, therefore you take that. I think if we use this as our fundamental principle, we should be able to find most of our problems correct. Okay, so we are going to thoroughly do it tomorrow. I needed to just to do maximize in case I do not find another example for maximize. Oh, sorry, is it maximize? Yeah. And then also I wanted to emphasize on the issue of software. Yes, we have done the software already. So now here we are doing this now. I did mention that the late last come last serve, first come first serve. The question required us to do first come first serve. The solution first come first solution below, then it's more like your ABCD. That's your first come first serve. Okay, so now we want to find the results now, but we need to find the flow. We have the flow and we have the lateness, né? So those are the new stuff that they are added on the table, the flow and the lateness. So the flow is just to determine six plus 2. 6 plus 2 is 8. So this one you do it in a form of a cumulative frequency. Sorry, you do it in a form of a cumulative. So 8 plus 8 is 16. 16 plus 3 is 19. 19 plus 9, when you remove 1, that's 20, 27 or 28. So when you add the 2 here, when you add this block, you find 6 plus 2 plus 8 plus 3 plus 9. You find 28. 28, okay? And when you add this, you find 6 plus 8 plus 16 plus 19 plus 28. You find 77. Then this we don't add because it's a lateness, né? So we need to, sorry, it's the due date. We need to find the lateness. So we're going back here. This is production. Né? This is what you're producing and the due date. So now you need to start with the due date when you substitute here. not with production. So the due date minus the production, how many days are there? We have a positive 2. And then the positive 2, what does it mean? It means that you are having 2 days in advance on hand. So you are reaching your target in 2 days more. Then a positive value becomes a 0. Because if you were late, it was going to become negative. Negative meaning you cannot satisfy. So the aim of this 8, which is dd, due date minus flow, due date minus flow, is to say whenever 8 minus 6 equals to, the aim is to find it as at 0, but now we are finding it as positive 2. However, there's a rule here. It's too late as a positive. This is a due date. You are still remaining with 2. If this is a calendar of 8 days, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. And then 8 is your due date. And you are able to deliver on day 6. There's a positive of 4 days. You are early by 4 days. The minute you surpass this, if you're writing it on the with a different color, say 6 days is what you're producing. The minute you are surpassing it, 9, 10. By 10, you have surpassed it by 1, meaning that this is still your due date. And the moment you go above your due date, it means that the customer is the one that is important. You're no longer able to reach their goal. You have planned that every week you're going to release products, and now you no longer reach their goal. That's why we are calculating lateness. How many days are you late? Then you mention, I'm late by 2 days. And you're late by 2 days. So now 6 now minus 8. You see now our due date is less. Our due date is now less. So 6 minus 8, it's a negative 2. So that negative 2, it means that you are unable to deliver. Here you could deliver, here you can't deliver by 2 days. You write it as a positive figure, guys. You write it as a positive figure. Okay, then 18 minus 16, which is, you're going to get a positive 18 minus 16 of 2. Then you do not write anything because of your due date is far from your production date. So that's a 0. Then we have 15, which is less, minus 19, which is bigger, then that is becoming a negative 4. Then we are behind by negative 4 days. Then we have 23 minus 28, which is, there's a deficit also. Let's confirm the 23. Yeah, 23. So now this one is going to be a deficit of 5 days. Then you count your days. It's going to be 11. You are late by 11 days. You are late by 11 days. Okay. So now You then apply these formulas there. Average completion time, which becomes sum of total flow time, which is 77 over the number of jobs. Number of jobs is 1, 2, 3, 4, 5. That's number one. Average completion time equals to 77 over 5. Is 15.4. Then utilization metric, sum of the flow 77 over total job process 28. Which is going to be 2.75. Then the average jobs in the system, three, which is sum of total flow. Everything is total flow here over the processing time, which is 28. Then here I wasn't supposed to use this. Then it's the sum of flow, total flow time, total work processing. I did this one wrong. How can I do wrong when I'm doing it here? This is the one here. 27 over. You see, I'm tired now. 27 over 28. Yeah, that is a. And then utilization. Yeah, but you guys need to make the point that you check this thing out, guys. I think I'm fatigue is getting onto my accuracy. The fatigue is getting on me. Please, you wrap up this. Although the questions in the book, they will slight change and not look like exactly this one. Okay, guys, I would like to thank you guys once again. We have pushed, and yeah, the ultimate goal has been reached even on my YouTube channel, and I have to always show gratitude for people who assist. So yeah, my channel is already at 1,000 subscribers, which is a good feeling. And yeah, let's keep on embracing industrial engineering. I know it has never been done like this, but we are doing it either way. Thank you so much, guys. Let us meet tomorrow, 8 o'clock for D1, 10 o'clock for D2. I cook you for one more time, and you'll be ready for your test and exams. I've already removed one problem from the test. Now I'm still assessing between assignment and sequencing, which one I'll remove because one must fall. And the answer, you will get it on tomorrow's class. If you don't come, you don't benefit to know that, and I'll tell them straight to not to tell you. I'll tell them straight not to tell you. But yeah, no, I have to admit I'm tired now. Ladies and gentlemen, thank you so much. Let me rest, and I'll have to still push for. I'll have to still push for tomorrow's class. I need to be refreshed.